Okay, we've got a first order differential equation here, and our first step is to rearrange it so we've got dy by dx. So we divide by sine x. So I've got dy by dx, take away y cos x over sine x equals sine 2x. Okay, and I could write that dy by dx, take away cot x y equals sine 2x. Now I've got it in this form, I'm going to use the integrating factor. So the integrating factor I equals e to the integral of whatever the y term is. In this case it's minus cot x dx. Okay, and the integral of cot x is on the formula sheet, so just again be aware the integral of cot x is log of sine x. So I've got equals e to the integral of minus log sine x. Oh, no integral, sorry. So the integral of minus cot is minus log sine x. I can't cancel the e's and the log until I move this minus. So I'm using laws of logs here. So it's e to the log of sine x minus 1. Okay, remember this is not arc sine of x, because that would be sine to minus 1x. This means 1 over sine x. So e and logs are inverses. So I'm left with 1 over sine x. Okay, so my integrating factor is 1 over sine x. Now I'm going to multiply everything by 1 over sine x. So back to me star up here. Multiply it all by 1 over sine x. And equals sine. Now the left hand side we know is going to be the differential every time of the integrating factor, which is 1 over sine x times y. Right, every time, I, y, every time. And this we know is 2 sine x cos x over sine x using the double angle formula. Okay, so we know that will leave us with 2 cos x. So I'm now going to integrate both sides. So I end up with y over sine x equals the integral of 2 cos x dx. So almost there, this one's a relatively quick one. Y over sine x equals 2 sine x plus c. Multiply both sides by sine x, so y equals 2 sine squared x plus c sine x. Okay. Finished. Be careful you don't do all the rearranging and then add the c on the end. As soon as you've done the integration, add the c on and then do the rearrangement.